This is the X570S Carbon EKX. MSI and EK coming together to deliver the ultimate monoblock performance, because you can squeeze even more performance out of your high-end AM4 CPU with a monoblock, right? Right? I mean, power is the limiting factor, isn't it? It's more interesting than that. And with Intel Alder Lake getting ready to launch, the performance crown that AMD has enjoyed for so long may be challenged. And this motherboard can tell us a little bit about what we can expect for the future. Okay, the future of AM4 and dotting the I's and cross the T's. Because one of two things can happen. Intel can take back the performance crown or not. And assuming that Intel takes back the performance crown, I don't think they're going to take back the performance per watt. And this motherboard will kind of show us why. So let's dive in, let's take a look. Let's see what EK and MSI have cooked up. There is something very satisfying about an absurdly large motherboard box. I'm sorry, it's just, remember the old MSI, like the giant GPU boxes that were just absurdly huge, and then the GPU inside it was much smaller than modern GPUs, but the boxes were at least 8 times as large, 8 times the volume. I remember those days. Pepperidge Farm remembers. Dinner is served. In the box, we have a box that says EK Loop Accessories. This is a leak tester, so you can actually pressurize your loop and see if it's going to leak. Those are handy. Under this foam, we have the Monoblock. So this is one machined piece of metal that comes in contact with your coils, your VRM, and your CPU. The fluid chamber here will hit your CPU, and then it'll spread out over the CPU. It'll go through the flow indicator and spread all the way around, hit your VRMs and other stuff that may be hot, and then it exits the block. And here we have the actual motherboard. Now before we get to the motherboard, there's yet more accessories under the foam. So here, this is your thermal pads. You're gonna need these. This is what goes between the VRM and the chokes area of your monoblock and the CPU. The CPU itself gets thermal paste as per usual, but you have to cut these up and sort of place them so that they're gonna make good contact with the surface mount components on your motherboard. We've got our AM4 mounting backplate, standard issue. Got our nice Wi-Fi antenna. It's repositionable. It's not those cheap rubber duck antennas. We've got all of our RGB, digital RGB, as well as our 50/50 accessory headers. We've got our EK mounting kit, our drivers and everything else on a USB stick, which is reusable. We've got our SATA cables. We've got our M.2 mounting hardware, yet more M.2 mounting hardware. MSI comes with a keychain, Phillips and flathead screwdriver, and a lint brush, so you can dust the lint away. There's also a temperature connector, so you can have an external temperature sensor for your motherboard. You can use that to monitor your GPU temperature directly, for example. Some really cool metallic stickers for cable labels and things like that. Get the MPG MSI stickers. Really not much of a manual. All right, so directly into our CPU is our primary X16 slot. That's always directly into the CPU. And of course, one of our M.2 slots also directly into the CPU. That's pretty standard for most AMD AM4 systems. Then we've got our PCI Express by 4 connection to the chipset. Now that's where things get interesting. Things take a turn with this motherboard layout. So our PCIe E4 slot, that is X4 electrical, that's connected to that, and also M.2 number 4. So you can have a PCIe peripheral or an M.2 in slot number 4. PCIe E2 and E3 are connected directly to the chipset. Those will always work. M2_2, always connected to the chipset, that'll always work. M2_3 shares bandwidth with SATA 5, 6, 7, and 8. So if you're gonna use SATA devices, you don't wanna use M.2_3. SATA 1, 2, 3, 4, however, are directly into the chipset. They're not sharing resources with anything. Our LAN is a Realtek 8125B, also into the chipset, as well as our Wi-Fi AX210 and our ALC 4080 HD audio. I think this is a great layout for a board like this that is targeted at the gamer and enthusiast audience, as well as somebody that's looking for a relatively high performance desktop computer that also can run whisper quiet, basically nearly silently. More silent and it would be passively cool. As with most AM4 motherboards, the extra M.2 slots give us the option for more capacity, but if you're thinking RAID, wouldn't do more than a RAID 0 or a RAID 1 of 2 M.2 devices on this motherboard. The reason being that all of your M.2 bandwidth, except for the one that's through the CPU, goes through the chipset. So unless you got old or slow M.2, it doesn't make sense to use more than 2. You'd have to move up to another platform like Threadripper, which gives you a ton more PCIe lanes into the CPU. And this motherboard doesn't do anything fancy like, take the X16 for the GPU and split it into by 8 or anything like that. I think most gamers actually probably don't want that. You want more of a workstation class motherboard if you're going to try to add, 100 gigabit Ethernet or dual 25 gig Ethernet or something like that. That said, this does have a PCI Express by 4 4.0 slot into the chipset that you could mix and match high-speed peripherals on. I mean, that PCI Express 4x4 connection will certainly be fine for dual 25 gig Ethernet, you know, a Mellanox Connect X5, something high performance like that. It's not going to bottleneck, as long as you don't have any other insanely high bandwidth peripherals hanging off of the chipset. For connectors on the motherboard, we've got a 4-pin plus an 8-pin CPU power connector at the top edge of the motherboard. We have 3 4-pin fan headers, a CPU fan, pump fan, and system fan. We also got a rainbow LED connector, as well as a Corsair connector, and sys fan 2. They've moved the diagnostic LEDs to the top edge of the motherboard. I like that. That's sort of the new hotness, because, you know, at the bottom edge of the motherboard, it might be blocked by a really long graphics card or other peripheral. So I like that they're at the top of the board now. We got our 24-pin ATX power connector, our JUSB1 for our front panel USB Type-C. Then we've got our 8 SATA 6 gigabit per second ports. Just remember the breakdown that I talked about before, how some of them share bandwidth and some of them don't. JUSB2, which is our 30-pin 5 gigabit USB header. We've got another rainbow LED header at the bottom edge of the motherboard, our front panel connector, battery reset. There's an LED switch if you've got like external power and you're going to try to use this for a demo. 4-pin fan header, another 30-pin USB front panel header, so this gives you a total of 4 USB 5 gigabit plus Type-C. That works out pretty good. Got a USB 2 header, and then sort of a blank spot, and another USB 2 header. Above the one USB 2 header is that temperature sensor header that I mentioned was bundled right in the box. Then we got a power connector for external LEDs. You won't actually use this unless you're trying to show off the motherboard with no processor or anything like that, so don't use that. You get 2 more 4-pin fan connectors, and then there's an RGB header, and then of course our audio connection, which is on a separate part of the printed circuit board, which is nice for audio isolation. At the rear I/O, we have a clear CMOS button as well as a BIOS flashback button, so that you can upgrade the BIOS to support any future CPUs, or if your system won't post, you can clear the CMOS or flash a fresh BIOS without even having to open up your system. We've got a combo PS2 mouse and keyboard port, which is great if you're rocking an old, PS2 keyboard. I love those old Model M keyboards. We've got USB 2.0 Type A ports right below that, and the USB BIOS flashback port is the bottom one here next to the BIOS switch. Then we've got USB 3.2 Gen 2 10 gigabit Type A above our HDMI connection. The HDMI connection is if you're going to use this with a 5700G or another AMD AM4 CPU like that has integrated video. Although I would really recommend this board for pretty much the 5950 or the 5900X 16-core monster CPUs. Then we have USB 3.2 Gen 1 5 gigabits Type A. It's a stack of 4. Our Wi-Fi AX6 solution has our dual connections there. 2.5 gigabit LAN, that's our Realtek LAN. USB 3.2 Gen 2 10 gigabit Type A below that, and then a 10 gigabit Type C. And then our audio ports, which include an optical SPDIF out port. Do note that the motherboard I/O shield is pre-installed on this motherboard, and that is a very nice feature. Alright, getting started with this motherboard for the build, it's pretty easy. Take your processor, flip the lever up, make sure the processor is oriented the correct way. Gold corner, it's a gold corner. And there you go, you got your AM4 processor installed. Now you also need to do the monoblock, but that's not time yet. Grab the monoblock. Also grab the thing from the box that you forgot to take out earlier. Alright, you got your little baggie of screws and washers and nuts. We're going to need that. And then you got your baggie of thermal pads, 1 pieces. And so there's 1.5 millimeter and 1.0 millimeter thickness. The thickness of the pads do vary just a little bit. I think the 1.0 millimeter thick thermal pads goes across the chokes. That's the big gray things. And the thicker pad goes across the VRM at the bottom. That would kind of make logical sense, because otherwise it's going to be sitting too high and the chokes won't make good contact. And when you tighten it down, the thermal pad will be more compressed into the variability of the voltage regulation. We're going to sort of end up squishing the 1.5 millimeter pad around the VRM, which may help it a little bit. You might also be okay just cutting this out of 1.0 millimeter entirely. We'll just lay it right down. Now I know what you're thinking, it would be tempting to use that little strip on the VRM, and you probably could get away with that. We can try it. Because the thinner pads are usually more conductive. But you don't want to mix. Like, you don't want to use a 1.5 millimeter pad in one place and then, you know, another pad in the other, asking for trouble. Now there's a lot of little details on this motherboard to like all those M.2s and the dependencies that I mentioned about which thing is disabled and what thing is shared with what other thing. Well, it's actually labeled on the printed circuit board. You can see it's got SATA and PCIe and little indicators here to help you. There's other nice features like the back of the motherboard. See, it's got all these keep out zones. These are indicators to help you remember to get your motherboard standoffs in exactly the right place. You'd be surprised how many motherboard RMAs are caused by missing motherboard standoffs or motherboard standoffs that people have put in that there's not actually a hole for. Now normally, if you get a kit for, you know, an arbitrary motherboard, the motherboard is just using, you know, whatever cooling it has for its VRMs. And notice that the chipset fan is not connected to the monoblock. So the X570S chipset, the all new hotness of the chipset, must not run as hot as the previous chipset. Improvements in process. Well, it has been a while. The EK Ectotherm. Please remove before use. Sorry, use isopropyl alcohol to make sure that that is clean. All the mating surfaces. There are 5 of them. 1, 2, 3, 4, 5. The CPU. The way that it goes in is like this. It's like under the ledge. Line up your screw holes. And then you can kind of flip it over. Now here's your metal backplate and your insulating pad slash, you know, self-adhesive. This might have adhesive on it. If you peel one side, it would like stick. I'm not going to use the adhesive part of this. Now when you do this, you want to do it corner to corner, and you don't want to over tighten one corner. You want to kind of just very gently snug it and then snug the other corner, and then just keep alternating corners. And the reason for that is you want this thing to set flat on the CPU and mate up really well with the surfaces that you want to be sure that you cool properly. Now I can see that the CPU has made it up really well, but the 1mm pads are not quite thick enough. They need to be the 1.5mm pads. So I think it's 1mm pads on the chokes and 1.5mm pads on the VRM. So we'll switch out the pads and make that happen. All right, so with the correct pads in place, now we can tighten down the VRMs as well. So there's separate screws to help, you know, make sure things made up really well. So I'm gonna use a washer. Same deal basically, you don't wanna over tighten one side. You wanna just sort of go back and forth so that the pressure that you're applying is even. First thing when you get something like this assembled is also to remember to check your VRM temperatures. You can use a program for Windows like Hardware Info 64 or LM Sensors on Linux and just confirm that, you know, the VRMs are not suspiciously hot. That might indicate that you've done something wrong. All right, so that looks a lot better. We can see that our heatsink is really pressed well into the thermal pad and our VRM. It's making nice, good contact. What's the vector, Victor? Roger, Roger. This is already set up with our EK 360mm radiator, our Vardar fans in the front, and our EK kinetic pump. This is a DC pump. It's basically good to go. All we need is to mount the motherboard, get some fittings, some flex tubing. We're good to go. Well, for the tubing and the fittings, Micro Center's finest, as evidenced by the price tags. Stuff's so easy to work with. Now I've got all my tubes and fittings and everything else put together. Just need to give it a little bit of water. Wait, what if there's a leak? I know, we'll use the EK leak tester. Well, how does that work? Well, first you go to your EK Loop Accessories box and carefully unbox it. Some assembly required. So you get this bicycle pump looking thing. This is actually the gauge. Boom. This also looks like some kind of random bicycle accessory, and that's because it is. It's a pump. The The easiest way to test it is with the lid of your reservoir. Even before I put any water in it, gonna unscrew this thing in the middle here. Now we got a hole in the reservoir, but this thing will screw right in. Then make sure our valve is open. Unscrew this. This is our little protector. This protects the valve stem. So you gotta unscrew that. You gotta put this back though. And then this screws in here. Make sure that's good and tight, and then you just go into the green. Oh no, it's losing pressure. No, that means there's a leak somewhere, which is probably just that I haven't tightened this down all the way. I hear a leak. Where's the leak? All right, so you just keep testing with that until you get a satisfactory result. Tighten your fittings down, look for leaks, and then you can give it some water. Distilled water, that is. Minerals and other contaminants, not good for your loop. Do we have any leaks? One thing I really like about this fractal case, it's hard to imagine because it's got the sides off of it, but with the reservoir kind of near the top here, I can just pop the top off, fill it up. I got the tempered glass, I can see in it and do whatever I need to do, but it's pretty easy to get at the pump. The pump is the lowest thing in the loop if you don't count the bottom of the radiator. Yeah, I could go tubes down with the radiator, but I got some drive bays here at the bottom. I like this layout. Let's get some RAM in this and do some testing. So I got this thing put together, and this is our final build. I've got the MSI Supreme 3090. Yeah, I know, it would be nice to have the 3090 on a water block. This system can definitely handle that. And then we've got our CPU underwater, and I've also added 64 gigabytes of GCL Trident Z memory. That's the 64 gig kit that runs at CL18, but is 3600. So it's pretty fast considering it's a 64 gigabyte kit. Yes, that is multiple ranks on a single stick of memory. So you get the performance benefit there. Gaming performance on this thing, like as one would expect, was a dream. But the question for me was, how much farther could I push the 5950X? Well, not that much farther, it turns out. Those are already pretty well bend to heck and back. But I just happen to have a 5900X that I swapped in instead. The 5900X, much to my surprise, actually had a lot more headroom than the 5950X. See, the 5950X, out of the box, its absolute maximum clock speed is 5.05 gigahertz, and that's the boost that you'll just see for a fleeting moment. It spends most of its time around, 4950, 5000, somewhere through there. The 5900X is about 100 megahertz slower. For overclocking, we've got the choice of Precision Boost Overdrive and a bunch of custom options in the MSI BIOS. As was with the way that MSI does most things, this BIOS unlocks way more options than MSI normally unlocks. We actually have a lot of options. There's even LN2 mode in the BIOS on this board. But with the overclocking options in the BIOS, I still couldn't do quite as good as I could do with Ryzen Master on Windows. With Ryzen Master on Windows, I could get our CPU-Z single-thread benchmark up to an even 700. Yeah, pretty impressive. Our multi-core score, of course, with a 5900X is not quite as good as with a 5950 because, hey, the 5950's got 4 more cores, but in terms of gaming performance and anything like that, yeah, rocking real good. So for single core, 2 cores, 5.05 gigahertz on the 3900X. I was really kind of hoping that I could get more clock speed than that, but it's not really heat that is Ryzen's problem with overclocking. That said, it did generate quite a bit of heat, and our EDC and TDC values, it was allowed to consume up to 500 amps, but really it was just, north of 150 watts at times for very fleeting moments. The system was very quiet, as expected, and that was nice, considering how far that we're pushing it. This kind of custom loop cooling for Ryzen for performance, it's kind of overkill. Ryzen just, heat is not the limiting factor there. It's something else, something deeper down. Unless you go liquid nitrogen, and then all bets are off with liquid nitrogen. But if you want a quiet system, a whisper quiet system, even with that overclock, this was a barely audible system that worked out real well. What that tells me about Alder Lake, no crap. Now at the beginning I mentioned, hey, this might give us some insight into what might be coming with Alder Lake. Well, I was hoping that I would be able to push the single thread performance here past 700, well past 700, because some of the leaked benchmarks show some pretty high numbers there. I wasn't able to do that even on a relatively recent 5900X. So I think we're going to be relying on AMD to update the formula, maybe add some cache, come out with some other kind of new, or maybe there's going to be a lull, a 3-month or a 6-month lull where Intel's back on top, if the leaks are true. At the time that I'm doing this video, I don't really know. For this build, with the 3090, 4K above 60 FPS, the 5900 and the 5950X will absolutely do everything that you need to do for gaming and everything else. So what more could you want? At least right now, at this point in time. Could the next generation be that much of a leap forward? Time will tell. I'm Windell, this is Level 1. I'm signing out, and you can find me in the Level 1 forums.